Have you noticed that AI is that one thing that's popping up in every single app? I've been building Spring apps for well over a decade now, and I haven't seen this much feature excitement since cloud computing became a thing. So in this video, I'm going to teach you how to integrate a large language model, that's LLM, with your Spring Boot app today. Breaking it down, we're first going to cover the AI concepts that you need to know to get going. We'll explore what we're going to build and how the pieces fit together. We'll download and run an LLM using Ollama. We'll run a React frontend that I've built for you, which will give you an easier way to interact with your app. And then we'll build our Spring Boot app completely from scratch to integrate with our LLM. And be sure to stick around until the end because there are some gotchas that I need to point out for you. So let's get going. I'm going to assume that, like me, you want to use the LLM to do useful stuff, and you're not necessarily interested in deep diving the maths and perhaps magic that makes the LLM work. You want to drive the car. You don't want to optimize the valve timing of the variable valve lift system. Variable valve timing of the variable valve lift. With that in mind, here's the concepts that you'll need to know. The large language model, or LLM, is an algorithm, and it's built to work in a similar way to our brains. We're able to train LLMs on really large data sets, and that allows us to use them to generate content like text and images, and even use them to review content that we've written. They can give their opinions. And how do we do all of this? Well, it's through something called a prompt. In its simplest form, a prompt is something that you give the LLM in order to get something back. And this typically takes the form of a plain old string. An example might be, write me a story about cats, to which the LLM will write us a story with a bunch of feline characters and the hijinks that ensue. But if we dig a little deeper, there is more to the prompt than just a simple string. We next need to consider roles. The first role we'll consider is the system role, and this is a string that we give to the LLM which describes how it should behave and how it should interact with us. For example, I might give a system prompt to an LLM which goes, "You are a very knowledgeable pirate. Please answer all questions by speaking like a pirate." And you can imagine what will happen. Everything we get back from the LLM will then be in pirate speak. The second role that we'll consider is the user role, and this is one that you're already familiar with. For example, the cat story from earlier. So this is where we can ask questions, ask content to be generated, things like that. The user role combined with the system role gives us our output, which in the case of our story about cats will almost certainly be written as if spoken by a pirate. Oh, what a time to be alive. The third concept is tokens, and we're only going to touch on this because you just need to know it exists, not necessarily how it works. When you give a prompt to an LLM, which might contain that system role and user role, it's not just one big long string. It's actually broken up into lots of little tokens. The reason that you need to know about tokens is because there is an upper limit to the number of tokens that you can give to an LLM in a single prompt. What that upper limit is really depends on the LLM that you're using. So now that you're all clued up, let me show you what we're going to build. There's a few common use cases for using an LLM. One is to give it a prompt and have it generate some content for you, and another one is to give it some content and then have it offer its opinions. We're going to go with the second one and give our content to the LLM and then have it review it. To keep it simple for the moment, we're only going to ask the LLM to do one thing, and that's to review our content and then tell us if it thinks it's true or complete fiction. Our implementation is going to take the form of a Spring Boot application, which is going to use the Spring AI library to interact with an LLM that we're going to have running locally through Ollama. The React application that I've built for you will sit in front of that Spring Boot application and give us a nice easy way to interact with our Spring Boot app and see what the LLM has to say. So with that done, let's move on to Ollama.
Hi.
Ollama is one way to run LLMs locally on your machine. You can think of it sort of like an LLM package manager. Or if that's a new concept to you as well, you can think of it sort of like one of those fast food apps on your phone. You look over the menu, you pick the thing that you want, you order it, and instead of crispy pancake rolls delivered to your door, you get a fully trained LLM running locally, ready to use. Tasty. So let's open up a browser and head over to ollama.com. So here we are on ollama.com, and we can see here that Ollama runs on all of the major operating systems, although Windows is in preview. That said, I'm using it on Windows at the moment, and it seems to be working fine. So we're going to simply download the installer. Click on download for Windows there. Or if you're on Mac OS or Linux, download it for your respective operating system. So once that's downloaded, you'll simply need to run through the installer, and that will install Ollama on your machine. Then you simply need to run it, and then you can interact with it via the command line. So to make sure Ollama is installed correctly here, I'm going to type Ollama --version, and that will tell me that I'm using this particular version here, which means Ollama is installed and it is running fine. The default model that Spring AI wants to use is going to be Mistral, which we currently don't have downloaded. So we need to go ahead and do that. And the way that we're going to do that is via the command Ollama pull Mistral. And that will go ahead and download Mistral to our machine. So it's roughly 4 gigs. So that could take a little while to download. Once it's downloaded, we can then interact with Mistral via Spring AI, via the Spring Boot app that we're about to build. So while we're waiting, let's move on and run the front end so we have a nice, easy way of interacting with our Spring Boot app once we've built it. Now, it's a very simple application. We type something in, it sends it away to the back end, and then it displays the suggestions that the back end has given us. The code for the front end is available for free from the DevTira community site, so link in the description below for that. So once you've downloaded the front end, just open up a command prompt, open up a terminal, and navigate to where that code is. And we're simply going to run npm install in order to install all of the dependencies. And then we're going to run npm run dev in order to run the application. Great, so that seems to be running. So let's go visit this address here in our browser. So here's our front end, pretty simple. We type things to the left in here. And then on the right, we get the suggestions. So things that the backend suggests for us, which in this case is whether or not it thinks what we've written is true or false. Now you'll notice that we're getting some errors at the moment simply because we haven't written our backend yet. But if we take a look at our networks panel, type in some more here, we can see that we're getting a request made to API suggestions, and it's currently getting 500. In the payload for that, we can see that we have the content here, and that's the content that we've written up here. Now you might be wondering, why is there 3 parts to this UI? We're typing on the left, that's obvious. We're getting suggestions on the right, that's fine. However, in the middle here, why have we got this section? Well, this section is actually there to render what we see on the left here, but it also aims to underline statements that it thinks is false and true with various different lines, red for underline if it's false, and then green if it thinks it's true. And we'll see that feature working, maybe, a little bit later. So with that all done, all that's left for us to do now is to build our Spring Boot application. So let's head over to the Spring Initializer at start.spring.io in our browser. So we're going to use Maven as our build tool. We're going to write in Java. We're going to use the current general release version of Spring Boot here, and then we're just going to type in some information to identify a project. Okay, it doesn't really matter what you put in here. It could be anything at all. And then for packaging, we're going to go with jar and not war. And now we get to add some dependencies. So our project is only going to need 2. So we click on add dependencies. The first one is going to be Spring Web because our front end needs a way of interacting with our back end. We're going to do that via a REST API. Now for the second dependency, we're going to use Spring AI and we're going to use Ollama. And this will allow us to interact with our Ollama LLM. So with that done, let's go ahead and generate our project and that will download it for us. Okay, that's downloaded. So let's go ahead and open that up in our IDE. So the idea with this app is that we're going to give the app some content. It's going to use the huge bank of knowledge that the LLM has, and then it's going to tell us whether or not the content that we've given it is true or false. So the first thing that we'll need to do is model our domain. So in our IDE here, I'm just going to go up to this package. I'm going to go new, create a new package, and I'm just going to call this one domain. Now, the first thing I want to represent is the request that the front end is sending to the back end, that thing that we saw earlier in our networks panel. So we'll go new Java class, and we're going to call this one content DTO. Let's just minimize that a little bit. So to keep things nice and simple, we're not going to use a class, but we're going to use a Java record. And we're going to declare inside of the parentheses here a single string called content. And that should be enough to represent the request that our front end is going to send to our back end. This string content is going to be whatever we've typed in. Now we're going to want to model the suggestion that the LLM is going to make. So I'm going to create a new class in domain here, and I'm going to call this one suggestion. So for the suggestion, it's going to be easier for me to implement it and then talk you through it rather than go step by step. So let's replace what we have here with this here. Now we can see the suggestion again is a Java record. It's got a title, it's got a description. So this is what the LLM is going to give us. It could be something like this is false. And the reason that it is false could be in the description, but we'll see what the LLM gives us. And then we have the start index and the end index. And that is going to try and give us the exact part of the content which it thinks is either true or false, which we can then use to underline. And talking about underlines, we've then got the suggestion type, which we have here is red, blue, or green. So red is going to be, this is false, green, this is true, and then blue is going to be somewhere in the middle, like it could be false. I mean, there's some parts of it that could be false. We're going to give it somewhere in the middle via that blue color. So now that we've got our domain model, let's move on to our service layer. So let's create a new package in here, services, and then we'll create a new Java class in here, and we're going to call this one suggestion service. And we'll make this one an interface. So we need a way of getting suggestions from the LLM, and this is exactly what this service is for. So we're going to have a single method on here that's going to return for us a list of suggestions, and we'll simply call the method suggest, and it takes an argument, which is going to be the string content. And let's just import list. There we go, that's imported. So that's our suggestion service there. So let's create a new package called impl, where we're going to put our implementations. Create a new Java class, and we're going to call this one fact checking Ollama suggestion service. What a name. And we'll say this implements the suggestion service. Then we got our red underline. So let's go implement methods, and then we have our method stub. Okay, so let's start at the top here by adding a service annotation, and that will ensure that it can be injected where we need it. An empty list isn't great. Like, that's not what we want returned from this. So we're going to need to call our LLM. And the way that we do that is via the chat client. So I'm going to create a private instance variable here called chat client. And then we'll create a constructor where that is an argument, and then that will allow us to inject it. Do that in a nice simple way by going add constructor parameter. So our chat client is now available to use. We can do so inside of the suggest method here. So this is where our knowledge of the prompt is going to come in. So we're going to go chat client dot prompt. And next we want to give it the system prompt, and that's going to set the context for our interactions with the LLM. So to make things nice and clean, I'm going to create a new variable up here with the system prompt in there. So this is the prompt that I've come up with, and it's by no means perfect, but it's okay for a first iteration. So I'm not going to read this in its entirety because you can do that yourself, but some things to point out. You are an expert fact checker. And then we described here what we want our response to look like. So we want it to mark inaccurate statements as red, and then some more details down there. And then we also say about the character index, so we can try and underline the statements which are going to be true or false with the correct color line. So if we then copy that and place that in the system prompt, now we get to give it the user prompt, which is simply going to be the content that's passed in. So content up here is going to be our user prompt. Scroll up a little bit, and now we'll use the call method. And now we're going to use the entity method. And this is a really great feature of Spring AI, where it allows us to easily take whatever the LLM gives us as a response and then turn that into a POJO, so a plain old Java object, which in this case is going to be our suggestion. So we're actually asking for a list of suggestions, so we can't just type suggestion in here. So we need to use the parameterized type reference. And we can see that list of suggestions already populated. And then we'll just do a semicolon, and that will be our implementation. However, before we move on, let's just do a check on that content to make sure it's not empty. So we're going to say if content is empty, and then in that case, we're just going to return a new array list, just an empty list. There we go. So when the content is empty, we're going to send an empty array list. Otherwise, we're going to send whatever the content is onto the LLM via Spring AI and look to get back a list of suggestions. And I think that does it for our fact-checking Ollama suggestion service. So we can see that the chat client API seems to be pretty nice here, but the thing is we don't actually have a chat client bean available to use in our Spring context right now. So we need to create one. So if we go up here and create a new package called config, I'm going to create a new class in here, and I'm going to call it AI config. Let's put the configuration annotation on the top there. And then we're going to create a bean declaration, chat client, do a return, and then we can use the chat client builder. Now, the thing about the chat client builder, or chat client, I suppose, is that it needs a model. So we're going to, up here in the arguments to our bean declaration, do a chat model. And we'll pass that into our chat client builder. So earlier we installed Mistral via Ollama, and Mistral is the default chat model used by Spring AI. And although we have to declare a bean of chat client, we don't need to for chat model because Spring AI will do that for us. So we've done our domain, we've done our service layer. Let's now move on to our presentation layer. So let's create a new package up here and call it controllers. And let's create a new class in here, and we're going to call it suggestion controller. So let's put the REST controller annotation on the top here because we are building a REST controller. And let's do a request mapping where the path is suggestions. Now we're looking to use our suggestion service in here. So we're going to go private final suggestions service. There we go. And let's get a constructor with that in there as well. There we go. So our suggestion service is now going to be injected in there and it's available to use. And now we're going to implement an endpoint and it's going to be a post endpoint and it's going to return a list of suggestion. And we're going to call this one get suggestions and it's going to have a request body. Okay, let's import list while we're here. And it's going to need a request body and that's going to be the one that we've created up here, which is going to be our content DTO. The implementation of our endpoint is going to be fairly straightforward. We're simply going to call our suggestion service, call the suggest method on there, passing in content DTO dot content. And then we'll do return, which will return the list of suggestions. So if we've done everything correctly, that should be the first iteration of our backend available to use. So let's go over to the main class here and let's run this. Okay, the application is up and running on port 8080. Let's go over to our front end and see what we get. So here we are back in our front end. So let's give it a go. So let's type something we know to be true on the left-hand side here. The sky is blue. Okay, failed to fetch suggestions. That's kind of strange. Let's try deleting that and then go the sky is green. More 500s. Okay. The sky is the sky. Okay, accurate. So why are we getting 200s here and getting 500s up here? Well, this is one of those gotchas that I wanted to point out earlier. So if we take a look, we can see that there's not a lot of information in there, to be honest. So let's head over to our backend and let's just expand this up so we can actually see it. There we go. So this is one of the gotchas that I wanted to point out. So Spring AI does a fantastic job of taking what the LLM has given us and then converting that into a POJO, which in this case is going to be our suggestion. However, it does this via JSON. And if the JSON isn't valid or if it doesn't represent our POJO, then, well, what can it do? Not a lot. And that's what these exceptions are all about, because the JSON that's been given back from the LLM isn't valid, doesn't represent the suggestion class, even though Spring AI has asked it to be accurate to represent our suggestion class. And this is one of the limitations, one of the gotchas with an LLM, which is you can ask for something very, very specific, which in this case is a JSON representation of a suggestion for the content that we've given it. But doesn't mean it's going to give you it back. It could give you something completely different. It all depends on all of the different variables that LLM is operating on. However, if we go back to our front end now and take a look at one of the requests that was a success, we can see here that yes, it's given us a suggestion, the title, the sky is the sky, no description on this one, start index 0, end index 18, and it's a green line. And we can see here the suggestion on the right, the sky is the sky, so the title there, no description on this one, but it's green, which our front end knows to be accurate. And of course, we can see that green line there. Of course, we can type anything that we like into this now. Let's say something like rabbits can eat carrots. Rabbits can eat carrots, correct. However, this is another limitation, or perhaps the same limitation that we pointed out earlier, which is you can see the line here doesn't underline the whole of the phrase. It only goes as far as the C in carrots. And if we take a look at the response here, we can see that the end index is 17. So the LLM hasn't given us the proper value for the end of that particular phrase. It hasn't given us something specific that we've asked for. But again, that's just the nature of the beast when it comes to LLMs. Now, this wouldn't be complete if we didn't try and get the negative case. So we're going to go with carrots eat rabbits, which we know to be false. So after a few goes, we can see that we've got two suggestions back here. Rabbits can eat carrots is accurate, and then carrots can eat rabbits is inaccurate. However, we do also see that the green underline extends way past what it should do, and we don't have a red line in there. If we take a look at the response here, we can see that the rabbits eat carrots goes all the way up to index 37, which is what we see here. We don't see the red line because the end index goes way past what it should do. So a little bit odd, another limitation of the LLM. So how can we fix this? How can we make it better? So one way to make this better is by doing a bit of prompt engineering. So we can go into the fact-checking Olama suggestion service and change the system prompt and try and get more regular, successful responses back from the LLM. Prompt engineering is now a whole new discipline, and it's becoming even more important the more we use LLMs. So updating that system prompt is the first thing that we could do. Another thing that we could do is try a different model. Of course, you can get several different models via Ollama, but by using Spring AI, you can actually point to things like ChatGPT and Claude as well. So there's loads of different variables that we can play with to try and improve the output that we get from our app. If you're interested in swapping out the model for a different model, then I'll leave the code on how to do that on the DevTira community site in the write-up, so do check that out. That said, the basic approach should remain the same. However, I am conscious that we did zoom through a bunch of Spring Boot concepts, so if any of those were a bit confusing or you want some more information on them, then be sure to check out this video here, which is the Spring Boot for Beginners course, which takes you through everything. I see you over there.